Okay, let's turn on some lights. So it seems. Suppose the elasticity of technical substitution is 0.8. The profit share, here, the profit share is 0.4 and the profit rate is 0.10. Calculate the quantitative impact of a 5% increase in real wages on those variables of interest. So we begin with our elasticity of technical substitution 0.8, our profit share at 0.4, and our profit rate itself of 0.10 or 10%. I'm measuring it there in decimals. And we have the shock. The shock is a 5% increase in the real wage. So, in other words, the proportionate change in the real wage is 0.05. How is that going to impact on our variables of interest? Our first variable of interest, we're told, is employment. Well, our conceptual tool is the elasticity of demand for labour to the real wage. And if you like, in calculus terms, dLdW times WRL minus that, we know that is equal to the elasticity of technical substitution divided by the profit share. Therefore, we know that is 0.8 divided by 0.4, and that is 2. And therefore, we're entitled to say that, just to use now a finite change representation, we're allowed to say that that is approximately equal to 2. So, in other words, the percentage change in employment is approximately equal to the rate of change of that times 2. Therefore, we can say that our change in employment is minus 2, 0.05. Oh, it's minus 0.10, or if you like, 10%. So employment declines by 10%. And we obtain that by invoking the elasticity of demand and then using our what our theory says about the determinants of the elasticity of demand. What about output? Well, the key thing there to remember is that labour is produced. Labour helps in the production of output. So there's an elasticity of output to labour. dy dl times L over W. What is that elasticity? Well, we know that dy dl is equal to W. So it's WL, sorry, y it should be, WL over Y. But that is just 1 minus the profit share, because the profit share, of course, is equal to rho, defined as rho k over Y. So the elasticity of output to labour is 1 minus pi, which is, under our assumptions, 0.6. Therefore, we can say that, going to use a finite change, the change in output relative to the change in labour, proportionate change in labour, approximately equal to 0.6. Therefore, the change in output is equal to, approximately equal to 0.6. What's the change in labour? Oh, we figured out what the change in labour over there. It was minus 0.10, which is minus 0.06, or if you like, 6%. So output falls by 6%. It's not surprising that output falls, employment has fallen. But output, we can be more precise, we can say output has fallen by 6%. What about the average productivity of labour there? Well, the average productivity of labour, trivially, since it's just the ratio of output to labour, we can say that the proportionate change in the average productivity of labour, trivially, is just the rate of change of output minus the rate of change of labour. Okay, it's not economics really, it's just a piece of simple arithmetic. And we've computed both these things, haven't we? We've computed the rate of change of output, it's negative 0.10, and we've computed the rate of change of employment, it's that, and that is minus 0.04, or if you like, minus 4%. So the average productivity of labour, this can't be right.
Output
What's
change
going on
is
there?
Plus 0 point.
Output is changed by 6%.
Yeah.
Switched it.
Output falls.
Yeah,
Output
6%.
falls by 6%.
6%.
Oh, okay. Output falls by 6%. Employment has fallen by 6%. Thank you for pointing it out. 0.06. Employment has fallen by 10%. Output has only fallen by 6%. So that's plus, plus. So the average productivity of labour has risen by 4%. What about the average productivity of capital? Well, it's the same sort of thing. The average productivity of capital is Y over K. Therefore, trivially, the proportionate change in the average productivity of capital is the proportionate change in output minus the proportionate change in capital. Oh, but that's just zero. When there's no change in capital here. So we can just say that the change in the average productivity of capital is the change in output, which is minus 0.06 or 6%, negative 6%. So the average productivity of capital has fallen. The profit rate, I'll now move over here for the profit rate, because people probably try and find it hard to say that. The profit rate. What can we say about the profit rate? There are various ways of coming at the profit rate, but perhaps a rather elaborate way of coming at the profit rate is to invoke, it's as good as any, is to invoke the neoclassical factor price frontier. The elasticity of the profit rate to the wage rate is equal to minus WL over rho K, which is equal to minus WL over Y over rho K over Y, which is equal to the negative of 1 minus the profit share over the profit share. So that's the elasticity of the profit rate. But we know that that is equal to minus 0.6 over 0.4, so it's minus 1.5. So we can say, we use an approximation, the rate of change in the profit rate to the wage rate is equal to minus 1.5. Therefore, running out of space, can use a little bit of space. Therefore, coming down here, the rate of change of the profit rate is equal to minus 1.5 times the rate of change of the wage rate. Oh, by assumption, that was 5%, wasn't it? 0.05. So, minus 0.075. That's the rate of change in the profit rate. We haven't quite finished our answer though. We want to know what the profit rate is itself. And continuing down this direction, if I may. Therefore, the change in rho is equal to minus 0.075 times rho. So you're saying, what are you saying? Where are you? Ah, okay. Therefore, the change in rho is equal to minus 0.0075. Is that, as you're pointing out, is that. So if rho started off at 10, it's now 10% or 0.10, it's now that adjusted down by that, and I think that leaves us as rho is 0.0925 or 9 and 2.5%. That's what's happened to the profit rate. Okay. Yeah, 9.25%. Are there any questions or comments about what I've done there? Yes.
Will that be the change in W?
Yes. Well, here, yes, that's right. That should be a calculus. D rho dw. That's right. Thank you. Are there any other comments or remarks? The final one we want to do is the profit share. The profit share. Well, there are various ways we can try to do that. The profit share is rho K over Y. So one way we could do it is we could say, okay, trivially, the proportionate change in the profit share is equal to the proportionate change in the rate of profit plus the proportionate change in the capital stock minus the proportionate change in output. Now that's one way of proceeding, because we've obtained all those already, haven't we? We know that this was minus 0.06. This, by assumption, is 0. And this, we found it over there, was minus 0.0075. Therefore, to write that out properly, it will be minus 0.0075 plus 0, which we can forget, I guess, minus 0, minus 0.06. That's, okay, well, that's certainly going to be, I got that all right, that is the, is there something 0.0075? That's right, I thought there were too many zeros in there. That's a proportionate rate of change, isn't it? Yeah, thank you for pointing that out to me. So, we can now make that minus 0.015. So the profit share has fallen by 1.5%. Oh gosh, what's 1.5% of that? Well, I think 1% of that, 1% would leave us, it's a bit complicated, isn't it? All we want to do is get 98.5% of that. Okay, so somebody can figure it out for themselves and see if I'm doing it right. I would say that 0.4 times 0.985 is equal to 0.394. So I infer that the actual profit share now is 0.394. Right? And it's like a 1.5% decline from its magnitude before. Are there any questions about that? Right. So how do our quantifications, because they're quantifications, are they consistent with our theoretical propositions in lectures? Well, we certainly know employment has fallen, well, we'd expect that with the real rise in the real wage. Output has fallen, again, we'd expect that. The average productivity of labour, that has actually risen. Oh, can that be consistent? Well, what does the average productivity of labour depend upon? The average productivity of labour is a concave function of the capital labour ratio, isn't it? So we might have started off at the beginning with the capital labour ratio there and an average productivity there. What's happened to the capital labour ratio? It's increased because labour has decreased. Labour has decreased. So the capital labour ratio has increased, and therefore if I draw my diagram correctly, you'll be able to infer that the average productivity of labour has increased. So yes, that sort of checks out with our contention. What about the average productivity of capital? Well, that's very similar from coming over here. That's a similar sort of logic, isn't it? We know that the average productivity of capital is, according to our theory, is a concave function of the labour capital ratio. So we started off with a certain labour capital ratio, like that. What's happened to the labour capital ratio? Well, the labour capital ratio has obviously fallen, hasn't it? Well, we know it's fallen because labour has fallen, therefore the labour capital ratio has fallen. So the labour capital ratio has fallen, therefore we'd expect the average productivity of capital to fall. Oh yes, the average productivity of capital has fallen. So that checks out. What about the profit rate? Well, the wage has risen, the profit rate has fallen, that certainly checks out. What about the profit share? Well, you remember this story about the profit share? The profit share depends upon the capital labour ratio, but in various possibly different ways. So profit share. If the elasticity of technical substitution is less than 1, it's negative related to the capital labour ratio. If the elasticity of technical substitution is greater than 1, it's positively related to the capital labour ratio. We've made it less than 1, therefore this is our panel which is relevant. So it might have been that we started off with something like that. What's happened to the capital labour ratio? Well, as a student pointed out, it's increased because labour has fallen. So the capital labour ratio has increased, and therefore the profit share has fallen. And yes, we have seen the profit share has fallen. So it checks out with our theoretical propositions. Are there any comments about that? Okay, let's now go on to question 2. Question 2 says that in 1998, in an attempt to reduce the number of persons unemployed, the French government passed a law reducing the numbers of hours a worker might work in a week. So maybe from 40 to 36 hours, this sort of thing. But requiring employers to pay the same weekly wage to them regardless. So the weekly wage was not allowed to be reduced, it had to be the same. Now if the elasticity of technical substitution is 0.5 and the profit share is 0.3, how would this legislation affect the number of persons in work? It's meant to increase it. What would it in fact do, according to our theory, under those assumptions? Now I guess the key point to remember here is that our theoretical object, L, is actually, it's not the number of people working, it's the total amount of work done in, say, hours. L is the amount of work done in hours. Now, the number of people employed is clearly going to be a matter of the number of hours worked divided by the number of, so the total number of hours worked divided by the number of hours each person works. So if I can let E be the number of people in work, that is going to equal the total amount of hours worked, L, divided by H, where H is the number of hours each person works. Okay, just trivial thing. Therefore, we can say that the rate of change in employment is equal to the rate of change in hours worked minus change in H over H. Okay? Well, this thing here is just given by policy, by law in fact, and indeed it's negative, it's a reduction. The question remains, what is this thing here? And of course, we refer to the dependence of the total amount of work done upon the wage rate per period of time, or the hourly wage rate, because W isn't like an hourly wage rate. So the change in L over L, we know what that is, it's like that. Isn't it? It's that sort of relationship. So the change in L over L, we've just done this before, is minus, what was the elasticity of technical substitution in our assumption? It was 0.5.
Excuse me, I'm sorry to trouble you. I was teaching here a few hours ago and I left my USB key.
Did you? Do you want to go and get it?
I'm sorry. Excuse me. You're very kind.
0.5 over 0.3.
Thanks a lot.
Okay, cheers. Right, which is negative 1 2/3. It's, what do you just call it, negative 5 over 3 times the change in W over W. All right, that's all very well, but we've just raised a question now, haven't we? What is this thing? What is change in W over W? It's the change in W over W is going to be negative change H over H, isn't it? So if the hourly wages were reduced by 3%, the wage rate would have increased by 3% because the weekly wage had to be kept the same, right? So we can therefore say that the change in L over L is equal to minus 5 over 3 times minus change in H over H. Well, let's now plug that back into our formula. So the change in E over E is equal to minus 5 over 3 times minus change in H over H minus change in H over H. What is that going to equal? 5 over 3, change in H over H, minus change in H over H. That is equal to 2/3 change in H over H. And that, of course, is negative. Employment has fallen. Employment has fallen. Oh, what's going on here? Well, the way we know what's going on Total work done has fallen. Total work done has fallen by this amount, and it's fallen because wages have risen. One way or another, this policy has increased the hourly wage rate, so total amount of work done has fallen. Total amount of work done has fallen so much that the number of people actually employed has fallen. So this policy has been counterproductive to its purpose. Must it be counterproductive to its purpose? Well, if you think about it, it all depends on this. It all depends on how sensitive, how large is the decline in employment for a given increase in W. You see here it's been quite sensitive. This number here is 5/3. It's certainly exceeded 1. Now there's no need for this number to exceed 1. If we had made a completely different assumption about the elasticity of technical substitution, for example, it could have been less than 1. And you can go through the arithmetic, and I'd rather not do it now, but you can go through the arithmetic to yourself, that if this was a smaller number, so this elasticity wasn't, say, just 5/3, but what if it was just 2/3? Okay? You can go through the arithmetic and you'll find that you'll reverse the inequality. So whether this policy succeeds in increasing employment or decreasing employment all depends upon the magnitude of the elasticity of demand. If the elasticity of demand exceeds 1, it will reduce the number of persons employed. If it is less than 1, it will increase the number of persons employed. So you see, the elasticity of demand is quite important. Variable, I guess, particularly whether it exceeds 1 or is less than 1. Are there any questions about that? Well, let me move on to question 3, because that question 3 is a little bit protracted in its solution. We now turn to the Tobin Q theory of investment. We're supposing that the real rate of interest is going to be 2% forever. It's expected to be that, and indeed the profit rate is expected to be 4%. I think it said forever. So we can say, now moving to question 3, R1 is R is equal to R1 is equal to R2, etc. forever. We're also supposing that rho 1 is equal to rho 2 is equal to rho 3, etc. forever. And why don't we just call that, because we'll just call that rho. Okay, that constant rate of profit. Our first question asks us is, calculate and obtain the decline in investment of a surprise tightening in interest rates to 2.2% forever. Okay, that's really the question. We want to know if R goes up from 0.02, if it goes up to 0.022, or if you like 2.2%, from 2% to 2.2 forever, what is going to be the impact on investment? It's going to impact negatively on investment, we can sort of assume that. How much? What's going to be the size of that apparently rather small increase in the real interest rate, but permanent from 2 to 2.2%? Well, again, we call in an elasticity. What we want to calculate is the elasticity of investment to the rate of interest, though we're interested now very specifically in a permanent increase of the rate of interest, not just a one-off increase. So how do we get to the bottom of that? Well, firstly, recall our expression for the Tobin theory of investment. And you will recall that in its full glory, it discounts expected profits in all future periods, forever, etc. And then it deducts 1, where 1, remember, is the cost of a unit of capital when investment is 0. So it's like the long run or equilibrium cost of capital. That is what investment depends upon. Not surprisingly, it's going to respond negatively to the rate of interest, because all the R's are down here, but we want to be more precise under our particular situations. Given our assumptions that the real interest rate is constant and the profit rate is constant, we can simplify that expression, can't we? Investment B is equal, we'll just call it rho over 1 plus r plus rho over 1 plus r squared. You know, if you went on with all these expressions, it would go like that forever, minus 1. Okay. And you can, a little bit of infinite progression arithmetic, you can show that given that this is going on forever, we're assuming that, that is actually equal to a quite handy little expression, rho over r. Okay? That whole infinite expression, just a little bit of present or infinite geometric series arithmetic, you could reduce that to that, and so we have this rather compact little formula under the particular circumstances of investment. We can therefore say that dIdr, remembering this is a permanent change, is simply minus 1 over b rho over r squared, isn't it? Therefore, that's all very well, but it's handier to actually think of an elasticity, so we multiply through by r. Okay, we can put r there if we like, and we divide by I. Okay, we can put down the bottom, what is I? Oh, here we go, it's 1 over b rho over r minus 1. Clearly there's going to be some cancellation to do there, which will make things handier. There's some cancellation there, there's some cancellation there, there's cancellation there, and there's a cancellation there, isn't there? And so our elasticity is rho over r over rho over r minus 1. And from our assumptions, that's 4 over 2 over 4 over 2 minus 1, and that is equal to 2. The elasticity of investment, which should be negative, of course, I've lost my negative. The elasticity of investment to a permanent change in the rate of interest is minus 2. All right, well, we still haven't got to our answer, but what we can now say is that to put that in a finite difference assumption, the change of investment over the change in the rate of interest over that is minus 2. Therefore, something is not quite what I want. I might look at this again. Minus 2 times change in R over R. Okay. It should be I, of course. That is I. Okay. This thing here, well, we know that's, ooh, what is that? Well, the rate of interest has gone from 2% to 2.2%. So you might, that's a 10% change, if I can call it that. 2.2 is 10% bigger, isn't it, than 2, right? So this expression in here is minus 0.10, like a tenth, okay? 2.2 is a tenth bigger than 2. And so what we have over here is minus 0.20, or if you like, 20%. Bang, that's our answer. Investment declines by 20%. Wow, that's a big number, isn't it? The real rate of interest, remember, is that on the face of it, that's a smallish increase in some sense, 2 to 2.2, but investment has declined by 20%. And on the face of it, we haven't made strong assumptions. We haven't assumed anything about the magnitude of B. It will be the same, whether B was large or small. We haven't assumed anything about the production function as such. We have assumed this quadratic function for the expensiveness of capital. We're essentially assuming that the expense of any given, total expense of any level of investment does follow not just I, but I squared all over B over 2. We have assumed that function, that's perfectly sort of arbitrary. It's the basis of the whole Q theory, which we went through in lectures. But beyond that, it's quite a general result. And wow, that's a big number. But it all depends, as we will see, on our assumption that it's a permanent rate of increase. We now go to the bottom of the page and ask ourselves, what would be the impact on investment of a surprise tightening in interest rates to 2.2% in the current period only? Okay, well, how do we go about that? Well, we have to think a little bit about our formula. We'll just come back here again. Absolutely nothing wrong with that, but now we're just changing R. R1 and all the other R's, R2 or 3, they're not changing. So we really can't proceed down this path, which assumed that the interest rate was going to change for all time. So what we'll do instead, we'll take that expression, this general expression for the Tobin Q theory over here, and we'll just begin by rewriting it a little bit for reasons which will prove useful. We'll take 1 over R out the front and park it out the front of the bus. And what we have remaining is row 1. We have row 1 over 1 plus R1. We have row 2 over 1 plus R1, 1 plus R2, etc., minus 1. Now we're doing that for a good reason. We also want to take on board our assumption that the profit rate is the same in all periods. So we can just, sorry, that should have been R2, it should have been R3. Excuse me. So what we can do is we can just, having done that, we can delete all these things. Same rate of profit, which we're calling row in all periods. So just scrub that out. That makes things simpler. That's our expression, and we can certainly derive that with respect to the interest rate. In fact, it's quite the current interest rate, quite a relatively simple, perfectly simple piece of calculus. What's it going to equal is minus 1 over B, all over 1 plus R, it's the current rate of interest, squared, outside of this whole expression. That's not going away. That expression is staying there. It's a multiplicative expression, so it's staying there. All these other terms, of course, the 1 disappears, right? There's no R. That just no, why did I say that? There's no reason for the 1 to disappear. I can't see why I said that. So I can't, why should the 1 disappear? So that remains like that. All right, that's in a way that's our answer, but you're dissatisfied with something there?
Only thing is, if you take out the 1 by 1 plus R,
Yeah.
shouldn't you
That's what.
multiply it?
That's what I'm doing. Thank you. Yeah, thank you.
Yeah.
When you take that out, sorry, you can only take it out here, can't you? Right?
Yeah.
This business. You can't take it out here. That's why I was getting. Thank you, thank you, thank you. So what we've got this add-on term at the end, haven't you? Which is simply minus 1 over B, I think, as far as I can tell. It's just sitting there. And that's why we forget about it. Yeah, good. Thank you very much. Very helpful. So, here we are. That's our answer, but it's not a very intelligible answer. Doesn't tell us much, right? So we have to work on it a bit in order for it to tell us very much. So how can we work on it a bit? Well, firstly, you see, we've got 1 over 1 plus R squared out here. Well, let's now multiply through. Having taken this term out the front, let's now put it back in. Let's take one of these 1 over 1 plus R and multiply it through. So we can now say di dr is equal to minus 1 over B, 1 over 1 plus R, and now we'll multiply through rho over 1 plus R plus rho over 1 plus R1, 1 plus R, plus rho over 1 plus R, 1 plus, you can see what I'm doing. I'm just multiplying it back through, plus etc. forever. Well, what good has that done us? Well, it can do us a little bit of good. Let's put R up the top here, and we'll put R up the top here also. We're getting closer to something. Finally, this is a little bit of salt we're adding to our dish. Though we're only differentiating with respect to the current rate of interest. We're only changing the current rate of interest. Let's evaluate this derivative under the assumption. Let's evaluate it at the point where all future interest rates are equal to the current interest rate, which is consistent with our original assumption. Original assumption, all interest rates were 2%, and then in the current period only, up to 2.2. So we're entitled to evaluate this under that assumption. So let's evaluate under that assumption. What does it do for us? I'll write it out here. I'll just say R di dr is equal to minus 1 over B, R over 1 plus R. And now, sorry, this is not very tidy. Now we're going to have all these expressions, rho over 1 plus R plus rho over 1 plus R squared plus rho over 1 plus R cubed, etc. Now, that's getting a little bit familiar, isn't it? What that thing is. We've seen that before, and we know that an infinite progression like that, a geometric progression like that, can be wrapped up into a tiny little expression, can't it? We can wrap that whole expression up into rho over R. Okay, that's what we can wrap it into. So what we now say, if I might write that down here, R di dr is equal to minus 1 over B, R over 1 plus R, times rho over R. Now we're getting very close. We can now, almost the piece de resistance, we just divide by investment. And we've now got an elasticity to a temporary change. People can't see that, so I'll write it over there. If I can first find a bit of space over here for that. What we've got is R, the IDR, where this is now temporary, I insist, is equal to minus 1 over B, R over 1 plus R. Finally, rho over R divided by investment. Well, what is investment? Well, we know what investment is under the evaluating at the assumption that interest rates and profit rates are constant. We learnt what it was before. It was rho over R minus 1, wasn't it? Cancellation comes. So our elasticity is now minus R over 1 plus R, rho over R over rho over R minus 1. Now we've seen this term before. What was this term before? It's the elasticity of investment to a permanent change in the rate of interest. Remember, we've seen that before. That's what we did in the first part of the question. That thing is the elasticity of investment to a permanent change in the rate of interest. So we've now got our key conclusion. This thing here, which is like the elasticity of interest to a temporary change in the rate of interest, is equal to R over 1 plus R times the permanent elasticity. A temporary elasticity is R over 1 plus R times the permanent elasticity. And that means it's going to be a lot smaller than permanent elasticity. Let's just think what R over 1 plus R is. That is going to equal 0.02 over 1.02, which is approximately 0.02, which is equal to a 50th. The temporary elasticity, the elasticity of a temporary shock to the rate of interest, is 1/50th of a permanent shock to the rate of interest. 1/50th. So you see, it makes all the difference, whether it's temporary or permanent, whether it's here today and gone tomorrow, or whether it's forever. 1/50th. We knew that investment fell by 20% in response to a permanent change in the rate of interest. So in response to a purely temporary change, the investment is going to fall by 1/50th of 20%. 1/50th of 20%, which is 0.4%. So that's your answer to the last part of the question, minus 0.4%. 1/50th of 20%. Okay, so that's fairly, as I say, protracted question. Thank you for some eagle eyes. They're always good to have. Are there any other comments or any queries about anything I've written up here or why I've written it? Okay, well, let's move on to technological change. Question 4. We have some data on the growth of GDP, capital employment in Australia over that 16-year time period, with an average at the bottom of the column. We're asked to compute for that period the mean magnitudes of the rate of change in the capital labour ratio, the average productivity of labour, the average productivity of capital, and finally, multi-factor productivity. Okay, so if I may now remove this and move on to question 4. Well, what the data which we're given, if you look down the bottom of that table, is that the average rate of growth of output over that period, in average terms, was 3.2. The average growth rate of capital, put a bar on it if you like, it's an average, is 3.1. The average growth rate of labour was equal to 1.4. And finally, the average profit share in the whole thing was 0.237. What is the average change in the capital labour ratio? Well, the capital labour ratio, of course, is that. So, therefore, the proportionate change in the capital labour ratio is just trivially the change in quantity of capital minus the change in labour. So trivially, that's 3.1 minus 1.4, that's 1.7. So on average, over that period, the capital labour ratio was growing at 1.7% per period. Okay, we'd sort of expect that in any period of growth, wouldn't we? There is capital, there's, production becomes more capital intensified. What about labour productivity? Well, labour productivity, that's just proportionate change in Y over L over Y over L. It's just a change in output minus a change in L. It's pretty obvious. And that is 3.2 minus 1.4, that's 1.8. What about the change in capital productivity? Well, that's the change in the average productivity of capital. That's going to be the change in Y over Y minus the growth rate of the change in capital. That is equal to 3.2 minus 3.1, that's equal to 0.1. Not very much. But you'll recall I earlier asserted that the average productivity of capital should be in quotes declining as capital accumulates. So it's even that little growth might be pause for wondering what's happening. But our answer will come in multi-factor productivity. What is the change in multi-factor productivity? Well, the rate of change in multi-factor productivity is equal to the rate of change in output minus the profit rate times the rate of change in capital minus the labour share, profit rate that I meant labour, profit share, minus the labour share times the growth rate of labour. That is what our measure of the multi-factor productivity is. And so it's not difficult to see that what that's going to be is 3.2 minus 0.237 times the growth rate of capital, that's 3.1, minus 1 minus 0.237, that's the labour share, times the growth rate of labour, that's 1.4. And you can compute for yourself that that is approximately, that is approximately 1.4, which is sort of unfortunate that these two numbers are the same. That's just the growth rate of employment, and that's the growth rate of multi-factor productivity. It's just coincidence, so it's got no significance. Okay? So that is the growth rate of multi-factor productivity. Right, so just to finish off this, I give some question, point to this question. We can see that 1.4 is pretty big, isn't it? It's about half total output, not quite half, getting close to half the growth of total output, right? We can see, if you like, that if we were to say, we know that the growth rate of output, we can decompose it into the change in output due to technical progress, plus the change in output due to increases in capital and labour. We know that this is 3.1. We know this is 1.4. And that would seem to be 1.7, wouldn't it? 3.2. Oh, that's sorry. 3.2. Plus 1. That is 1.4. Well, this is 1.8, isn't it? Okay, now, very quickly, use your answer to infer what would have been the rate of change in labour productivity and capital productivity if there had been no technical progress over time. Oh, we don't observe that, but we can infer it. We can infer it. Total output, 3.2%. That part which was due to technical progress, 1.4%. Therefore, what output would have grown by if there was no technical progress? 1.8%. That's what we're saying. Take 1.4 off 3.2. This is what we're seeking. What output would have grown by if there wasn't technical progress? 1.8%. And therefore, we can infer what would have been the change in labour productivity, the proportionate change in labour productivity in the absence of technical progress. It would have been the change in output in the absence of technical progress, minus the change in L. It would have been 1.8 minus 1.4. It would have been 0.04, which is positive, right? There's more capital per unit of labour. Surely the productivity of labour would rise. We can now also, in the same way, figure out the change in the average productivity of capital if there was no technical progress. That would have equaled the change in output if there was no technical progress, minus the change in capital. We know what, we've estimated what that is. That's 1.8. We've estimated what that is. That's 3.1. 1.8 minus 3.1 is minus 1.3. So the average productivity of capital, the average productivity of capital in the absence of technical progress will have fallen by that amount. And that, as I've said, is just what our theory predicts. In the absence of technical progress, the increase in capital per unit of labour is going to reduce the average productivity of capital. Right, so that's it. Are there any questions or comments on that? Okay, good. Thank you very much.